Allora, la prima presentazione della professoressa Alessandra Bertoldo che presenterà la laurea magistrale in bioingegneria. Metti pure qua così ti faccio
Ok,
tirare.
va bene. Benissimo, allora, laurea magistrale in bioingegneria e la prima slide è questa qui, che in realtà ricorda quella che è tutta la tradizione della bioingegneria a Padova. La bioingegneria a Padova nasce prestissimo, nel 1968, siamo tra i fondatori di quella che è l'ambito della bioingegneria in Italia, siamo un po' il Politecnico di Milano, ma come vedete è una tradizione importante e questa tradizione, come tutte, poi viene riversata nei corsi che man mano si sono stati raffinati, sono stati diciamo, adeguati nel corso di tutti questi anni, guardate, dal 1968 fino ad oggi. Adesso non vado all'interno di quelli che sono i vari percorsi, ma per sottolineare questo, la Padova è un elemento importante all'interno della bioingegneria italiana e non solo. Tant'è vero che attualmente, questa è aggiornata proprio all'altro giorno, afferiscono a questo, quello che sono alla laurea di bioingegneria, docenti che sono parte, vedete in G06 e in G3 fatto, queste sono quelle che vengono chiamate, caratterizzate insieme, formano quella che è il nuovo settore che viene chiamato IBio, ingegneria, bioingegneria.
Su Zoom, scusate,
Sì, sì.
su Zoom sia condivisa correttamente, forse non è condivisa.
Ok. Allora, questi due settori assieme fanno IBio, ripeto, ingegneria e bioingegneria, sono 18 per quanto riguarda il pezzo relativo all'IC06, sono 7 docenti per quanto riguarda la parte invece della bioingegneria industriale e poi ci sono però tanti altri docenti che fanno parte di quella che è l'erogazione dell'offerta formativa che vengono da da vari altri settori disciplinari o da vari dipartimenti, come appunto qui c'è solamente una piccola.
Scusa, che
Dimmi.
posto anche questo, penso che c'è.
Ah, perché mi
Sì.
ok, siamo. Quindi un arricchimento, pertanto vedete che ci sono anche dei dipartimenti che sono dipartimenti di medicina, perché sono, diciamo, stanno sempre di più entrando all'interno di quello che è il percorso della laurea magistrale in bioingegneria. Allora, andiamo un attimo a vedere qual è lo schema dell'offerta formativa per la magistrale. È suddivisa in 5 curricula, sanità digitale, ingegneria clinica, bioingegneria industriale, modelli analisi dati biomedicali, bioingegneria delle neuroscienze e bioingegneria della riabilitazione. Chiaro che qui si evidenziano delle zone di specializzazione, è chiaro che comunque verrete fuori che siete bioingegneri e che sia in qualche modo abilitati a entrare all'interno di quel settore della biomedicale in generale, con sicuramente poi le caratteristiche delle vostre più attenzioni verso un certo percorso di stato nato, ma comunque diciamo sempre la formazione è comunque avendo un occhio che non siate settorizzati su un settore molto specifico, ma comunque abbiate le abilità per poter poi proseguire in tutto quello che sono gli aspetti possibili della bioingegneria. Allora, andiamo alla prima, che adesso, eccola qui, sanità digitale e ingegneria clinica, andiamo a dare un attimo un overview di quella che è un po' la formazione di questo percorso, dove vedete qui OB significa che sono obbligatori, quindi non si possono cambiare, e vabbè, qui c'è l'anno e il semestre, penso che in questo momento vi interessa poco, ma essenzialmente la struttura è obbligatori, dovete farli. E per quanto riguarda gli SSD, CPU, penso che anche qui possiamo un attimo sorvolare. L'interessante è vedere che ci sono dei corsi sia in italiano che in inglese. La laurea magistrale in bioingegneria è una laurea magistrale in italiano e inglese, se vedete, che significa che essenzialmente la persona deve sapere italiano perché parte dei corsi sono erogati in italiano, ma parte sono anche erogati in inglese, quindi metteranno statistici, lavorazione dati di segnali biologici che costituiranno, e li vedrete quasi fissi per tutti i curricula perché sono, diciamo, fondanti per quelle che sono le nostre conoscenze, e poi machine learning, bioimmagini, biomedical wearable technologies, clinical engineering, analisi dati biologici, sistemi di decisione, e questo vedete, diabete, sanità digitale e salute pubblica. Questo è un MED 13, quindi erogato, è obbligatorio, erogato da in ambito medico, erogato da un docente della scuola di medicina. Biosensor, moderazione geometrica, robotica medica, computation geometrica, qui vedete non sono obbligatori, ma dovete scegliere 15 CPU, CPU sono questi, tra questo pacchetto che è messo a disposizione, quindi qui comincia ad avere un po' di scelta e sicuramente poi ci sono i corsi a scelta con cui completerete quello che è il vostro percorso. La prova finale vale 24 CPU, mi soffermerò un po' più avanti, è una prova importante. 24 CPU sono tanti, sono il 20% di quella che è l'attività formativa complessiva, quindi è una prova finale, è una tesi che va cercata in maniera adeguata e costruita in modo tale da completare il vostro percorso. Principali sbocchi lavorativi, adesso sono anche qui veloce, l'industria ovviamente, per quanto riguarda l'industria, sistemi di monitoraggio real time, di parametri biomedici, funzionali vitali, sistemi informativi sanitari, ospedali pubblici e privati, c'è ovviamente una parte dell'ingegneria clinica che qua dentro, e società specializzate nella gestione della tecnologia in sanità nell'health technology assessment. Ovviamente tutti danno poi la possibilità di poter entrare nei centri di ricerca e di eventualmente fare anche un dottorato. Secondo, bioingegneria industriale, anche qui vedrete gli obbligatori, c'è un pacchetto di obbligatori che è uguale esattamente per tutti, e vedete anche qui anatomia funzionale, bio 16, erogato da docenti di anatomia, quindi non ingegneri, ma sempre della scuola in realtà di medicina. E all'interno di questo c'è una prima differenziazione per cui uno dovrà scegliere uno dei due pacchetti obbligatori, questo che diciamo è più focalizzato sulla biomeccanica computazionale e sulla meccanica ancora computazionale, quindi l'applicazione di tutto quello che è la capacità di descrivere la struttura di un organo applicata all'insieme clinico, poi alla chirurgia in generale, che invece una focalizzazione sui biomateriali attraverso questi due pacchetti. Quindi o questo sarà da fare in maniera obbligatoria. Poi di nuovo c'è un pool di corsi su cui si può fare una selezione chiaramente limitata, perché è una selezione importante per finalizzare il vostro profilo. La prova finale sarà per tutti da 24 e una serie di corsi a scelta, sempre se vedete, modellazione geometrica, manufacturing per biomedical components, human neuromusculoskeletal modeling, l'ingegneria cellulare dei tessuti, translational, di struttura meccanica dei materiali. Qui vedete alcuni corsi lo stesso in inglese, altri invece in italiano. Principali sbocchi lavorativi, dispositivi chirurgici, dispositivi protesici, dispositivi per la riabilitazione, quindi quello che è la costruzione, l'interfacciamento con quello che è il corpo umano di questi tipi di dispositivi, e una possibilità anche di entrare in quello che è l'utilizzo di dispositivi non solo per la riabilitazione, non solo diciamo, come obiettivo la clinica, ma anche nell'atto sportivo, essenzialmente. Anche questo è un ambito dove tutto questo può essere applicato. Laboratori di ricerca, strutture ospedaliere, anche questo è l'ambito, e chiaramente ancora università e centri di ricerca. Andiamo a modelli di analisi dati biomedicali obbligatori, questo è il pool di corsi obbligatori che si svolgono appunto nei 2 anni della magistrale, qui focalizzato sull'analisi dei dati quindi, e sulla modellizzazione, quindi modeling, methodology, Physiology and Medicine, metodi statistici per la bioingegneria, elaborazione di segnali biologici, che vi ho detto essere i 2 corsi che sono trasversali per quasi tutti i curricula, tranne quello della metodi statistici in particolare qua è dappertutto. Machine Learning and Data Science for Bioengineering, bioimmagini, matematica, cell biology, analisi dati biologici, controllo biological systems, diabete, sanità digitale, salute pubblica, che era quello di cui vi ho parlato anche nel primo curriculum, sempre dal docente della scuola di medicina. Anche qui un pool di corsi da cui scegliere, tutti in questo caso in inglese, vedete di nuovo un MED qui dentro, questi sono e ovviamente come vedete vi faccio sottolineo che ci sono appunto quello di cui vi dicevo, non c'è solamente il 506, il 534, ma ci sono colleghi che vengono da altri settori che comunque dedicano o totalmente o parte della loro attività nell'ambito della bioingegneria, quindi Statistical Biology, Computational Genomics e Model Solved by Fluid Flow. Ordinario 24, corsa scelta, questi che abbiamo proposto, ovviamente corsa scelta, e questo vale per tutti i curricula, questi sono corsa scelta che in qualche modo suggeriti, voi avete sicuramente la possibilità di introdurre dei corsi a scelta tutti quelli che adesso vi sto mostrando. L'unica cosa è che questi corsi a scelta saranno anche tutelati nel senso dell'orario, quindi resi compatibili con gli altri corsi che sono qui presenti. Ufficiali di scopi operativi, ovviamente in industria, aziende che progettano algoritmi o sono ricerca inerente all'analisi modellistica di dati, segnali, immagini biomediche, industria del settore biomedico, aziende ospedaliere e industria particolare per cui farmaceutica e alimentare, dove queste competenze sono particolarmente richieste. Università e centri di ricerca è quel un po' il mantra che si ripete perché per chi ha la buona volontà sicuramente questa laurea dà la possibilità di proseguire, di poter applicare anche cercare un dottorato o entrare in qualche centro di ricerca. Questo sto andando indietro, scusate, bioingegneria per le neuroscienze, e no, questo è il pool degli obbligatori, gran parte in inglese, ci sono metodi statistici, laboratori ovviamente biologici, moduli metodologici, perché anche qui è importante avere delle conoscenze di modellistica, Imaging for Neuroscience, bioimmagini, hanno un ruolo importante in questo settore, biomarkers, precision medicine e drug development, Bioengineering for Neuroeducation, Neurophysiology, Neurocomputation, Neurotechnology. Questo è il corso, come vedete, che viene ripartito ancora in questo modo da un docente che non è della scuola di ingegneria. Questi sono i pool da cui scegliere: Neurobotics, diciamo Medical Engineering for Cell e Bioingegneria cellulare dei tessuti. E anche qui sottolineo sempre, questi sono settori di persone che non sono del settore 06-34, ma partecipano alle attività. Prova finale 24 e corsa scelta sono questi. Ci sono dei corsi nuovi rispetto a quello che è l'anno precedente, in particolare questo Bioengineering for Cognitive Neuroscience, ma ce ne sono stati altri, non ve li ho sottolineati perché idealmente voi vi iscrivete a questo e quindi questa è l'offerta, però la presentazione che noi facciamo ogni anno è anche perché effettivamente ogni anno noi aggiorniamo queste offerte formative, cerchiamo di stare sul pezzo e di seguire quali sono i trend nel settore. Dove andare? L'industria nanotecnologica, che è un'industria diciamo, in rapido crescimento in questo periodo, aziende che producono tecnologie semiotiche uomo-macchina, sistemi neuroartificiali, tecnologie per monitoraggio e stimolazione cerebrale, ospedali pubblici ovviamente, sia per l'operazione delle immagini ma anche per la parte della diagnostica, per l'aiuto alla diagnostica, non che noi facciamo diagnostica ovviamente, e aziende specializzate su meditazione per applicazioni di neurologia e quindi tutto quello che è elettroencefalogramma, magnetoencefalogramma, scanner di risonanza, eccetera. Università e centri di ricerca, ripeto, dappertutto. Bioingegneria dell'abitazione ha anche questo grosso pool di corsi che sono obbligatori, anche qui potete vedere alcuni in italiano e alcuni in inglese, meccanica di studi biologici, metodi statistici, organi artificiali, elaborazione di sistemi biologici, sports, quindi qui vi dicevo che c'è anche questa attenzione verso il mondo sportivo, verso l'alto sportivo, machine learning, bioimmagini, Bioengineering for Neuroeducation, robotica medica e neurophysiology, che avete visto anche nell'app ed è il corso erogato dal docente della scuola di medicina. Da qui abbiamo tutto essenzialmente obbligatorio e abbiamo solo questo di corso scelta e anche qui si vedono quelli che sono erogati in inglese e quelli che sono erogati in italiano. Principali sbocchi lavorativi, ricerca e sviluppo nei centri per la ricerca per la robotica, nella progettazione sistemi biomimetici o anche esoscheletri, industrie biomediche per progettazione e produzione di dispositivi impiantabili, servizi ospedalieri di ingegneria biomedica, le strutture straordinarie pubbliche e private, che è un po' tutto quello che si è ripercorso anche all'interno dei vari curriculum, per dire che la preparazione è una preparazione certamente che porta a una specializzazione, ma comunque che rimane la possibilità di anche adattarsi in ambienti diversi. Ecco, tutti i docenti che partecipano a quello che è la laurea magistrale in ingegneria svolgono attività di ricerca inerenti alle tematiche che insegnano e quindi proprio per questo per essere aggiornati nel settore, per mantenere anche il corso che magari rimane quello come nome negli anni, ma in realtà se voi andate a vedere poi il materiale man mano cambia perché siamo una magistrale, perché noi facciamo attività di ricerca e quindi aggiorniamo. E i corsi aperti sono spesso multidisciplinari, è difficile da farvi notare, ma ve l'ho detto un po', no? Non c'è solamente quello che è caratterizzante, quello che è il mondo di bioingegneria, bioingegneria, ingegneria nel campo della biologica, nel campo della biologia, dove il termine biologia è molto esteso, campo come concetto, ma ci sono anche tutti i docenti che vengono da settori della stessa ingegneria o comunque fuori che partecipano al completamento dell'offerta formativa. Le lezioni, molte lezioni, molti corsi, quasi tutti, ma non 100%, comprendono sia attività di erogazione, diciamo, in modo tradizionale, quindi erogazione della teoria, che però attività di laboratorio. Tutti i corsi hanno questo tipo di simbiosi, un pezzo di teoria e un pezzo di applicazione. I turni, questi sono i laboratori informatici, non ci sono solo laboratori informatici, ci sono anche laboratori, diciamo, più dedicati alla parte del trattamento dei biomateriali, però sto per farci capire, laboratori informatici, se abbiamo turni, abbiamo delle aule abbastanza capienti per fare turni con al massimo 40 studenti e ci sono sempre i docenti, ovviamente ci sono anche i tutor a supporto di quello che sono le attività di applicazione che mettiamo in atto. Poi appunto ci sono altri tipi di laboratori non solo presso il DEI, ma ci sono altri tipi di laboratori che vengono erogati in altri dipartimenti e la tesi magistrale comunque che ripeto è quella di 24 CFU, ecco una tesi importante, una tesi su cui adesso noi stiamo facendo un percorso un po' mirato in modo tale da poter aiutare nella scelta consapevole di questo che è un momento, ripeto, che voi scegliete, ma estremamente importante. Sono 24, sono essenzialmente 4 corsi da 6 CFU, su cui voi potete scegliere qual è, diciamo, cercate perlomeno di scegliere qual è l'ambito in cui volete cercare di mettervi in gioco. Per questo ambito appunto deve essere un po' riconosciuta all'interno della bioingegneria e c'è tutto un percorso con cui noi interagiamo e cerchiamo di aiutarvi per dire se quello che avete individuato è effettivamente riconosciuto come bioingegneria oppure c'è qualcosa che vogliamo un attimo tuonare. Però, vi ripeto, questa attenzione è dovuta al fatto che per noi questo momento, che è una vostra scelta, diciamo di cosa sia un guidato e anche informativo effettivamente. Il corso ovviamente può essere fatto all'interno di laboratori di laboratori di ricerca che sono qui all'interno dell'Università di Padova, possono essere fatti anche presso laboratori di università al di fuori dell'Italia o anche l'Italia al di fuori di Padova o presso aziende. Quindi il panorama è ampio e per poter sfruttare per esempio la parte di poter fare la tesi all'estero oppure comunque per poter fare un periodo anche all'estero, vi ricordo che ci sono due possibilità, una è l'Erasmus Plus, poi c'è il bando per quanto sono la parte del bando RIS e il Time. Non sono qui, non sono io quella che sono l'addetta a queste cose, quindi ve lo lascio come informazione, poi man mano vengono fatti poi degli incontri ad hoc su questo tipo di, quando uno è già iscritto, per andare poi bene a spiegare qual è il percorso che si può utilizzare. Per entrare, se avete una laurea nelle 8 e nelle 9, quindi da parte di voi, se avete con una laurea in ingegneria biomedica, si entra avendo un minimo di voto pari almeno a 84, quindi da 84 ok, va bene, fino ovviamente più su. Altrimenti, se uno non ha una laurea alle 8, in classe alle 8 e alle 9, allora deve rispettare questi che sono dei vincoli e quindi deve cercare di, all'interno di quello che è il suo percorso triennale o subito dopo il percorso, prima di iscriversi alla magistrale, farsi dei corsi aggiuntivi in modo tale da appunto rispettare di avere almeno 12 CFU tra questi SD, 18 tra questi SD e 20 tra questi SSD. Ripeto, questo solo se non ha una laurea in classe L8 e L9. Se ce l'ha, l'importante è avere un voto di laurea minimo uguale a 84 o ovviamente maggiore. La richiesta è anche di avere una conoscenza della lingua inglese a livello B2 recettivo. Statistiche, vado veloce perché non so quanto tempo sto occupando, comunque per dirvi che il tasso di occupazione è un tasso di occupazione che ci soddisfa assolutamente, in linea con tutte quelle che sono le ingegnerie, quindi qualche ingegneria anche superiore, qualche ingegneria ulteriore, ma assolutamente in linea. E in generale il percorso, se andate a vedere i dati, questi sono i dati di Alma Laurea, quindi se volete verificarli tranquillamente andate, sono accessibili, sono pubblici. Questo sì, la soddisfazione è alta, 94,4, si ricadono, questa è una soddisfazione generale, è una soddisfazione dei docenti anche elevata e il carico è di carta alla fine adeguato. E se studiare ancora il corso, l'81, più dell'80% ripete questa scelta. Bene, io ho finito, qui ci sono alcuni riferimenti e non lo so se vogliamo aprire adesso le domande, se ci sono delle domande, ben vengano. Io non so a caso se riesco a vedere un chat, non c'è nulla. Ok, nessuna domanda, sono stata chiarissima. Va bene? Grazie.
Ringrazio la professoressa Bertoldo. Allora, la prossima presentazione è adesso del professor Michele Rossi per il corso di laurea in ICT.
Yeah. We don't have to link.
Questo qua.
No. Link. No.
Vai. Allora, che è tornato? Eh?
Mandato come zia.
Mandato biglietto? Ricordo noi caricheremo poi queste slide e anche le presentazioni sul sito lauree.dei.unipd.it dove troverete le informazioni aggiornate. In questo momento non ci sono ancora le slide aggiornate, ma troverete. Perfetto. Lascio la parola al professor Rossi.
Grazie, benvenuti a tutte e a tutti.
Non ce l'ho.
Ok, oggi vi presenterò velocemente la laurea magistrale, parlerò in italiano anche.
Forse magari chiedi se ci qualcuno in inglese, magari è vostro perché
Devo presentare in inglese?
così anche poi
Ok.
per la registrazione.
Okay, so we're going to have it in English. So what is ICT? We start with this information and communication technology, which is what this degree is about. Is let's say quickly system for transmitting, sharing, and processing information. And this is what we do in the degree. So we have 5 curricula, and they are here. Today we'll present them to you. So you are looking at different topics. We look at communication technologies. We are going to delve into that later on. Cyber system, which is basically internet networking. Then we have multimedia systems, ICT for Life and Health, and research and innovation, which is a new curriculum about focusing on research. ICT is pervasive, we are everybody, all of us, we're using emails, phones, and everything. So we are surrounded by this technology every day. And this is growing also. Is a technology that is very successful. We have a lot of applications that we see every day. They are growing, virtual and augmented reality, IoT, smart cities, and Industry 4.0, autonomous driving. We are talking about mobile network security. Those are just a few of the topics that we have built the degree around, okay, so that we are covering within the curricula that we offer, okay. In this slide, what I'm showing you is material that we got from our labs. So this is to say that we have laboratories where we do this activity. So we implement the system, we do experiments because we are very much centered and very much interested in research activity as well, as it was said before. And we are doing research in sensing system, wireless sensing, IoT systems, so Internet of Things, sensor networks, autonomous driving as well. So we are looking at security, cybersecurity aspects. We are looking at multimedia and many more. So we are basically building all the curricula on our research interests that are also very strongly connected with the needs in the society and in the industry that we see. So we have a few technical enablers. Here we have a list of the most important, like we're mentioning multi-access edge computing, where we are fusing communication with computing technologies, multimedia systems, so video, audio processing, point clouds, also virtual and reality, and so on. We have new communication paradigms that are arising. We are talking about intelligent surfaces, so intelligent walls that can assist in the communication into the future, underwater communication networks, massive MIMO, which is about system with a lot of antennas, so very densely populated with antenna technology. We are talking about joint communication and sensing paradigms that are new paradigms in the 5G and 6G domains. We have a lot of machine learning and AI, artificial intelligence, that is being used by internet networks and all the protocols that we are using to communicate, even in cell phones, even in this technology. AI is becoming very important. Cybersecurity is becoming an aspect that is really so much important and will be even more important in the future, and we are also very much interested into that. Also in this degree, we have a lot of quantum security, quantum information, quantum computing, which is a new trend, and I expect that to be growing and to become a very fundamental cornerstone of ICT as well. And ICT is a growing field. Here we have a few numbers, and here I collected them recently from a market analysis. It's worth 74 billion in 2023 for Italy, and is expected to reach 113 billion from now to 2028. So the main growing factors that were identified in this analysis are the digital transformation, this Internet of Things that I mentioned, so Internet of Sensors, sensing system as a support to the industry especially, and smart cities as well. And then this 5G and beyond connectivity, so the wireless communication networks like this cell phone networks. And then there are emerging technologies like AI, blockchain, and quantum communication and computing that I was mentioning that are appearing, and they will be also enabling some major market investments. So this is what we did to this is our design behind this degree. So we at the basics of the pyramids, we have a solid background that should be coming from your bachelor, so from previous studies in the first 3 years. What we offer are the remaining layers. So we offer the green, the red, and the blue layer. The green is about cross-disciplinary tools. So, and here we have especially programming techniques, C, C++, also Python programming. These are the most important for us. Machine learning techniques, AI techniques, also optimization theory that we need to control ICT systems. Then we have the technological layer, the technology layer where we have communication, multimedia, transmission aspects, and then the application layer on top. Okay. And this is what we believe is needed by a modern ICT engineer. It's a master degree which should be flexible. We should be centered on the tools, the technologies, and the application, as I have shown to you before, by keeping an eye on the model development of ICT systems. So we're keeping an eye on 5G, 6G technology, Internet of Things, wireless systems, that how they are evolving, Industry 4.0, and virtual augmented reality, and so on and so forth. And this study path will allow you to shape your study, let's say, curriculum around three main pillars. One is the type of technology that you are interested in terms of communication, multimedia, or transmission media. The second is to focus on specific cross-disciplinary tools that you may need for according to the interest that you have. So it's programming tools, machine learning tools, optimization tools. So you can also choose there where to focus more. And then you have the application domain that you can select. So now we go to the study paths. Here we have 5 curricula, and you see we have 4, let's say, I don't say standard, but they are consolidated ones: communication technologies, multimedia, cyber system, ICT for life and health. And then we have a new one, which is the one on the right hand side, introduced in 2024. The new one is about building a career and possibly around research. So research and innovation is meant to for people who would like to, students who would like to have a very solid mathematical background, but at the same time, a lot of laboratory courses to see things in hands-on activities in practical means. And at the end of the fact, they may go to do research at the university, but also in research and development at some industry. And so this is a path dedicated to cutting-edge research activities somehow, and to expose the student to those research activities, involve the student within those activities in our lab. And the other curricula, from communication technologies to ICT for life and health, they have a structure which is pretty much all the same. They have 6 mandatory courses, then you need to pick 3 courses from a list. Those are still 3 core courses that are basically decided. The list will be decided on the specific path that you're choosing. Then you have 3 related courses from another list, 2 free courses of your choice, and then at the end you have research training or internship activity and the final thesis. All the courses, all the curricula, and all the things that we do here are in English. So all the material that you're getting, slides, everything from the professor will be in English. The lesson will be in English. Many of the lessons will be also sometimes recorded and uploaded as we do normally. Also, it is an international by design degree, so I would say roughly between 40 and 50% of the population is composed of international students. So yeah. Okay, so these are the first 4. Communication technologies, the focus on the C1 communication technology will be more on the specific technological aspect and system that we need to communicate. So here we have fiber optics, wireless communication system, multi-antenna system. We are talking about intelligent reflecting surfaces, quantum communication, mobile networks, Wi-Fi, 82.11, even underwater and satellite networks. Okay. So the focus will be there, not only, but you have a great focus on these aspects. Curriculum number 2 will be more focusing on the internet network. So this is more, let's say, in the protocol stack, it's a layer from layer 3 and then up. And here you're looking at cybersecurity aspects, still Internet of Things, industrial communication, Wi-Fi communication systems, and also all the protocols and algorithms that are needed to make, to build the internet, to make the internet work. Number 3, multimedia is curriculum focusing on especially audio video processing and transmission. So here we are looking at how to deal with multimedia signals. And you have the theory, you have the practical aspect, the labs, video image analysis and processing, and transmission of this data over networks. Number 4, ICT for Life and Health is about the tools, the ICT tools, especially machine learning based, to process and transmit data that is generated by human. Here we can use even wireless signal to monitor your body, your movement, or maybe even your heart rate, or maybe your respiration rates. I go through one example, and then the remaining ones I'll go very quickly because we do not have the time, but you will find the slides uploaded in the department website. Okay, so you can go, and also we have a website where you can go and check very carefully all the things. So this is an example of C1 communication technologies. So you have, as I said, in the left-hand side, the 6 courses that are mandatory. So these are, you need to do them, to take them. In the right-hand side, you have the 3 courses, the 18 credits. You need to select 3 courses among the list that is on the right-hand side. Of course, you see from the left-hand side, the courses that are mandatory are antennas, digital communication, mobile communication, wireless networks, multimedia communication. Those courses are centered on the specific transmission and communication technology over wireless, but also over fibers like fiber optics and so on. We also have neural networks and deep learning because even though your interest is in the specific communication technology, the modern engineer should know something about AI and should have knowledge about what we call cross-disciplinary tools. So this is why we expose you also to this neural networks and deep learning subject. And then you want to pick 3 courses among the list on the right-hand side. You see, we have many courses among them. We also have modern C++ programming, which I believe is very important, and photonics and remote sensing, optical networks, optical environment communication, millimeter wave devices, and so on and so forth. So here you have a lot of freedom to specialize your path according to your interests. And then again, for this curriculum in this slide, you see the cross-disciplinary courses. You need to pick 1 course on the left-hand side among complex optimization, cryptography, optimization methods for ICT. So you see, we have a lot of courses that are about mathematical theory and applied math. Applied mathematical theory for optimizing networks, for optimizing the systems is what we need very much. Also reinforcement learning, which is about AI system to control the system over time, basically. And then 2 courses that you need to pick among industrial communication, programmable algorithm devices, quantum meters, quantum optics and lasers, quantum technology. Then with the other curricula, I don't go through the list. It is the same structure. You always have the 6 mandatory courses. The courses are changing according to the domain, which is different. The topic that is different, but the design is the same. So you have 6 mandatory courses and then 3 courses to choose from a list. And then you have the cross-disciplinary subject to be picked among 2 lists on the left and right. Again, the list on the left is more theoretical or the same mathematical oriented with some tools to optimize, and the list on the right is more technological, okay, technology oriented. And then we have multimedia, and then we have also ICT for Life and Health. And of course, if you go and look at the program, you will see that the courses are selected to reflect the main area of specialization. And the last one is research and innovation, where we this is a little different. It is a special curriculum. We have 3 mandatory subjects, 3 courses, 3 out of 4, and in the list on the top. And these are technology-oriented foundational courses. This is communication, fiber optics, wireless networks, and computer vision. Then you have 3 courses out of 4 to pick among 4, and these are more mathematical oriented courses. So here we want to build the solid foundation of the mathematical tool and theories together with the technology that you need in the research in this area. Following that, we have some courses that were designed specifically for this curriculum that are all laboratory oriented, so 1 in optical networks, and then 3 advanced courses on wireless system, network analysis, and multimedia system. So you see they cover the 4 areas. The optical networks is about, as the name says, laser optics and fibers, communication over fibers. Then you have communication over wireless. Then advanced network analysis is communication over wired network. And then advanced multimedia is basically processing and communication of video, images, and so on. Okay, so the 4 main areas that we cover. And all these courses, they have, let's say, helping out. Half of the lessons are in let's say, theoretical with the professor, and half of them will be in the lab, working with the professor, and also alongside the PhD student and also the team, the research team of the professor, by developing something practical. So by looking at some concrete cutting edge research problem, and then the exam at the end will be about solving this research problem together with the professor and the team. Okay, for all the curricula at the end, we have 1 research training or internship activity, which is 9 credits, and 1 final thesis activity. So what is the research training or internship? The research training and internship is about an activity that you can choose whether you want to do it in an industry. Here we have some of our partners, not all of them, some of them. At the very end, in the last semester, it's a 2-year course, and in the last semester, you dedicate the last semester to the thesis and to the internship. So you can select whether you want to go to the industry. You go there and you basically work with them for 3-4 months, from 2.5 to maximum of 4 months. This is typical duration, and this is your internship, and then after the internship, you can continue with the full thesis and finalize and graduate. Then you can go, and this is what we call internship. You can also go for a research training, which is as an alternative to the internship. The research training, you do it instead of going to the company, you're going to have your activity in a research laboratory. The research laboratory can be anywhere. It can be here in Padova, can be in one of our partner universities around the globe. And and there you develop your 2.5, 3 months project, and then after that you can continue with the thesis. Okay. The full thing, internship plus thesis, will be worth let's say 30 credits. So you have 9 credits for the internship or research training, and the following 21 credits for the final thesis. Okay, so it is an international by design. As I said, we have a lot of people coming from many places around the world. Here we have just an example of the student that we got. We have a lot of mobility problems. So once you're there, as was said before, you have a lot of really possible problems that you can exploit, from Erasmus to SEMTI camp, also some partner university that you can go to. We offer double degrees, so there is also the time double degree program, as it was mentioned before. Right now, we have a time degree program with Denmark University, BTU, and also University of Lisbon, Louvain, Yokohama University, and Università Politecnica di Catalunya. Also, we have double degree program with University Polytechnica de Madrid and National Taiwan University. The statistics are very good. As it was said before, we are about 90%. The satisfaction rate is very high, 97.6%. These data are public, so you can find them in Alma Laura website. So also the employment rate is very high, about 90%, as it was said before. So all this data is in line with the good result that we have in this department for all the engineering, let's say, degrees that we have here. So job opportunities are many. These are just some of our partners, and you can the admission procedure, as was said before, if you have an Italian degree, basically in engineering, you just need to have your final score above or equal to 84, with at least 50 credits in the following topics, like math, physics, computer science, and telecommunication. Basically, you get direct access for the graduates from bachelor degrees in information engineering, mathematics, and physics, and computer science. They usually have direct access to this master. Okay, so I'm done. This is our website. If you want to go there, you find more information, some news also about what we do, the awards that we got, and so on and so forth. And then there is the email if you want to ask some additional information. Okay. Thank you. Questions? Okay, thank you all. You will find the slides uploaded, and also the recording, I believe, will be uploaded as well.
Thank you, Michele.
Thank you. Thank you.
So, next presentation is from Professor Matteo Meneghini. Now,
Angelo.
okay, please.
Okay, thank you, Pino. So let me get started here. I'm going to present the master's degree in electronic engineering, and the idea is the following. There are several information you can find online. So I will try to start from the motivation, then of course some technical details later on. So let me get started. So how do we organize this presentation? First of all, I want to discuss with you some global challenges. So the question is, why should we be studying electronics starting in 2025, and what are the challenges, or if you want, the opportunities that come for electronic engineering? That's the first part of the presentation. Then, of course, the next part of the presentation is going to answer the question, what are the intended learning outcomes? So what I'm supposed to be learning by studying electronics, and what are the expected jobs, which is also important. And then there is the last part, which is the study plan and tracks. I'm going to be relatively fast on this last part, because that's the information you can find also online. So in the end, there is no need to repeat everything. I will just give you a general overview. I will try to work more on moderation. So now, let's start a bit. We are, in a way, in the middle of a revolution, and that you know for sure. First of all, everybody's talking about AI. We are now in the hype of AI, and of course, that's going to pose interesting challenges for electronic engineering that I'm going to discuss in a minute. Then, of course, the next is a shift towards sustainable mobility. We have been using internal combustion engines for cars for a long time, but now we are shifting to electrical mobility, and also there, electronics is going to play a big role, and a large amount of jobs, position, and interesting research opportunities are expected to be found. Then, of course, there is an increasing usage of energy, and normally the amount of dirty energy, so carbon, gas, and others, which are currently being used, is increasing. And we need to try to mitigate that by using renewable energies. And I will discuss about energy and electronics for energy in a minute. And finally, of course, population is aging. So people are getting older and older. And of course, it becomes important to develop new healthcare tools and systems, which in many cases include a lot of electronics. And that's also another opportunity I want to discuss with you. So this is the framework we are moving in. This is the context that we will be working on in the coming years. So now, why these challenges are related to electronics? First of all, AI, artificial intelligence. Everybody is willing to use artificial intelligence right now. and there is a lot of interest there. But just a quote for some IEEE Spectrum magazine, if the AI revolution is going to continue at the current pace, within a decade, so 10 years from now, the GPUs that we will be using will need to have 1 trillion transistors each, which is 10 times larger than the current usage. So there is the need of studying novel microelectronics technology to be able to fabricate these very interesting digital chips to be scaled so that they contain 10 times the chips they have, the transistors they have right now. And the related courses and topics that you can find to study the aspects related to scaling of electronics and to development of these new technologies are for sure microelectronics, nanoelectronics, you see them then on the bottom of the slide, but also digital circuits for neural networks and advanced IC design. So there is one challenge of AI related to the development of the chips of AI and the study of the innovative solutions related to that. But there is another important challenge related to AI, which is even more worrying in a way, and requiring even more, contribution from the electronic students. This is another plot. In this case, the quotation is coming from the MIT Technology Review. They say so, an authoritative magazine of MIT, which is analyzing the latest trends in technologies and so on and so forth. They say by 2028, so 3 years from now, the power going to AI will rise to 326 terawatt hours, whatever that number means. That could generate the same emissions as driving over 300 billion times round trips from the sun to the earth. The other problem is that data centers are going to need that energy, and if they're going to be needing that energy tomorrow, they will need that energy from conventional fossil fuels. So in general, they say data centers are going to be trending towards dirtier, more carbon-intensive forms of energy to fill the immediate needs. So how can an electronic engineer try to contribute to mitigating the impact of technology, the negative impact that such technology would have on pollution, CO2, and whatever? There are several courses related to electronics and energy, including power electronics, optoelectronic and photovoltaics, but also all the topics related to microelectronics and nanoelectronics to make these chips for artificial intelligence more efficient on one end. On the other hand, to be able to develop efficient ways of creating and managing energy so that the energy consumption is much more sustainable. Next topic, I was talking about mobility, and electric mobility is becoming a reality. There are several contradicting theories and opinions on electrical mobility. So just to give you some numbers, I took a report, a very recent report from FIA. FIA is the International Federation of Automotive, which is exactly the same federation which organizes the Formula One championships every year. So they are, in a way, authoritative. And they just prepared a report, you can see a summary plot over here, where they show that basically the current battery electric vehicle can reduce the greenhouse emissions compared to a combustion engine vehicle by 43% over the whole 15 years expected service life of the vehicle. So effectively, even if at the beginning people were saying electric cars are not that efficient in terms of mitigating greenhouse emission gases, now there are reports showing that this is going to become a reality. And if that's a trend, and if the European Union is banning combustion cars by 2035, you can imagine how much electronics there will be under the hood of an electric car. And that's creating extremely interesting opportunities for students. For instance, willing to attend courses in automotive and domotics, which is one of the core courses of our master's degree, but also on optoelectronics and photovoltaics to try to study power components, power electronics, which of course is related to the management of power, efficient management of power from the battery to the engine and vice versa, and of course integrated circuits, because an electric car requires a huge amount of integrated circuits. Still related to energy, there is another key factor. We saw the consumption of energy is increasing substantially. So if the consumption of energy is increasing, now people will start using the fastest forms of energy that you can think of, which means coal, and in general, gas, and in the meantime, nuclear. How about the cost? We already know about the environmental costs of these technologies, but there is also the cost of energy. You can see from this plot right here that in general, the basically renewable energy sources are much have a much lower cost compared to nuclear, as you can see, but also to gas, which is somehow one of the most common sources of energy. So in a way, renewable energies are the only opportunity we have to mitigate the high energy consumptions which are coming in the coming years. So in the end, also here, if you are interested, there are interesting courses like optoelectronics and photovoltaics, power electronics, but also organic and molecular electronics that you can attend in order to study alternative ways and credible ways to generate renewable energy. You can see from the dot on the right that this is a nice reality. Sweden is fabricating and creating 65%, 66% of renewable energy across the whole energy they are receiving. And in general, for most European countries, the amount of renewable energy that they can live on is already above 40%, which is an incredibly large number. To make this credible also in the future, while the energy consumption will increase, of course, a lot of job opportunities will be created. There is another final interesting trend I want to discuss today with you. Population is aging. That plot here is showing the amount of elderly people we will have in 2050 compared to what we have right now. So a lot of people above the age of 65 and above. And at the same time, the governments are cutting money for the healthcare system. And that's something you can find on newspapers. So in the end, advanced electronic-based medical equipment will be necessary in order to somehow develop fast screening methodologies to be used in the hospitals and smart systems. Also on the electronics aspects related to the healthcare system, we have a full track which is called Biomedical and Healthcare, including some interesting courses which are related to the development of electronic tools for the biomedical field. Another challenge is related to the increased connectivity that we need right now. You have heard about 5G technology now, the 6G technology is under development, and in order to be able to operate the related networks, advanced radio frequency chips are necessary. And here we have some courses and tracks related to analog integrated circuit design, but also to radio frequency chips that have been added to our master courses right now, because these are really trending topics where our graduates can find easily jobs related to development of these advanced chips for communications. Finally, the last challenge I want to mention today is related to the increasing need of electronics for space and in general for the avionics industry. The picture on the left shows just some Starlink satellite, and the picture on the right shows that those satellites, which are becoming more and more popular right now, are operated in a very harsh environment, because there are many sources of disturbances, including solar radiation, for instance, which eventually can damage chips which are operating in space or in the avionics industry. On the other hand, we would like those chips to be highly reliable, because it's not that we can go up there in space and replace a chip, or that we can accept that a chip is failing on an aircraft, a commercial airliner, for instance. So there are several courses, including quality and reliability of electronics, but also courses related to IC design and microelectronics, where these aspects are somehow targeted. So what are the intended learning outcomes? What can I expect to learn with a master degree in electronic engineering? Of course, I can expect that once I graduate, I know how to master the analog and digital electronics. I know how to develop circuits for signal processing and also for power management. But I can expect also to be able to design integrated circuits like chips. I can imagine to become a semiconductor specialist, in which I know the basics of semiconductor science, and to apply that knowledge in many fields, including energy, renewable energy, but also automotive, space applications, as I was mentioning, bioequipment, and consumer electronics. These are the outcomes that I expect out of a course like this. And after discussing the intended learning outcomes, I would like to also give you some perspectives for career and job. And that, of course, includes, for sure, R&D engineering, because all the topics I have mentioned are highly innovative in terms of research. So most of our graduates end up working in the R&D field, either developing new chips or studying new strategies to handle energy. They can become semiconductor specialists if they want to work closer to the most innovative technologies. Or they can work as test engineers to validate new technologies. In any case, you can imagine yourself either developing new projects, like at the beginning a team member and then a team or project leader, or you can imagine yourself having a foot in the laboratory where you test these new technologies and a foot in the office trying to develop and design newer products that can be used also, for instance, as in the telecom field or in the Internet of Things field. And finally, of course, there are great opportunities also for academic researchers and for continuing your path as a PhD student. No need to say that there is a very high need of engineers in this field. These are just some random screenshots taken from journals and newspapers. Let me talk a bit about the tracks we are proposing. In general, the structure is the same as the other courses you have seen. Everything is in English, and we have several opportunities for Erasmus all across Europe, plus a couple of dedicated Ulisse programs to Japan, one with Kyoto Institute of Technology, the other one with Nagoya University. And those are becoming very popular because spending some time in Japan can be a very good opportunity. The master thesis, of course, is for 30 credits. But I want to just let you know that we have designed 6 different tracks, which are related to the aspects I was mentioning earlier. So starting from nanoelectronics and photonics, electronics for energy, but also integrated circuits, if you have the passion for chips, biomedical and healthcare, which is not an alternative to bioengineering. If you want to study bioengineering, you go study bioengineering. Here it's related to the aspects related to electronics in the biofield. So it's a completely different story. Consumer electronics and domotics. And finally, smart industry and automotive, where you basically talk about cars or you talk about automation, because basically electronics for automation, which is a key in the industrial environment in order to be able to somehow automate the manufacturing processes in our industries. Now, what's the plan of courses that you can attend? We have decided that there are 6 courses that are somehow mandatory for every student willing to study electronic engineering. All the rest can be chosen by you, according to some rules, of course. So the 6 mandatory courses are related to the aspects I was mentioning earlier. There is something, for instance, on analog integrated circuit design, where you discover how to develop chips. One on power electronics, where you study how to develop electronic circuits for handling energy. One on microelectronics, where you learn the basics of semiconductor science. One on microwave devices, which is related, of course, also to the aspects related to transmitting signals, and so on and so forth. And these are mandatory, mostly done in the first year by the students. Then, of course, you can start with the 6 tracks. And now I don't want to go in the detail of each track, because this is really information you can find on the internet. But you can find that for each track, besides the mandatory courses that you see on the top, you have some track-specific courses that you can attend to. Just to make an example, if you want to go for the nanoelectronics and photonics, you will have some courses on, for instance, nanoelectronics, on optoelectronics, but also on biophotonics and so on and so forth. And that will characterize your training. So you will be a great electronic engineer.
ये सब सारी चीजें पढ़ के जा रहे हो जो तुमने मुझे बताया, ये सब पढ़ लिया तुमने?
Yeah, that's a good comment.
कितना दिन पहले एग्जाम दिया?
Okay. So that basically everybody will be a great electronic engineer, but with a focused preparation in one of these fields. Then you will be able to do every job, but in principle, your core knowledge will be in that field. You have 3 tracks on this slide and 3 other tracks on the next slides. And this you can look at in your own room once you're back home. But the key is that these tracks are kind of flexible. So if you love the smart industry and automotive track, but you like one exam or one course from electronics for energy, you can also present your own study plan in which you mix the 2 together, provided that some rules which are described on the internet or basically also implemented in the study plan submission system are respected. Last couple of comments. Here are the websites where you can find all the information, so I don't need to explain this. There is another great opportunity, which is offered by Infineon. Infineon is a big electronic manufacturing company. And Infineon Italy, which is very close to here and which is hiring a lot of our master graduates, is offering 2 study prizes of €5 each for students, good students enrolling in the electronic engineering degree. So the opening for this evaluation procedure will be later on, after September, so that you can graduate. And this study prizes are in memory of Alessia Lovato, who was a former student of ours working at Infineon. And since she was the great example of a female engineer, these two study prizes go, one to a male engineer and one to a female engineer, so that we can also try to compensate a bit the gender gap and try to encourage also the participation of both genders, in this case, to this kind of course. These are the plots prepared last year, I think, by our director on the satisfaction of all students related to our master courses. And in general, the electronic engineering has very good scores, exactly as the others in our department, because they are all good in the end. I like pretty much the fact that most of the students would re-enroll to this master course at the end. Officially, I would say that I would not enroll again, because after the master course, such an interesting master course, I would like to go and start working in the real world. But in the end, we are pretty glad about this score. So at the end, this is concluding my presentation. I wanted to start from some global challenges, just to give you some motivation on the context that you will be working in after graduating. And I've tried then to describe what are the various tracks that you can follow, attend to, if you enroll an electronic engineering degree. And that's basically concluding my presentation on this.
There are a couple of questions in the chat.
Okay, let me try to open them. First question is, would you say that to somebody who has studied computer engineering at a 3 years degree can study smart industry and automotive pattern, or is something that shouldn't be done? As you might have understood also from the previous presentation, our master degrees are mainly made in a way that you can basically transfer from any of our bachelors to any of our masters, depending on your passion and of course, of your interest. So in the end, there is no specific prerequisite that you should have in order to transfer from one bachelor to the electronic degree course. And that's also true for the other degrees. So in the end, what I would say is that in principle, you should follow your passion, and that can be done in a way. Why choose a path in electronic engineering rather than electrical engineering if we want to study in the field of electrical mobility and energy management? That's also another very interesting question. The difference between electrical engineering and electronic engineering. Of course, once again, it has to do with what you like. Electrical engineering, in several cases, has to do more with electricity generation and distribution at the grid level. Electronic engineer has to do mostly on and the energy part of electronic engineering, mostly it has to do with the handling of electrical power at system level. Like, for instance, the development of circuits for managing the battery in an electric car, what they call the BMS, the battery management system. That's done by an electronic engineer, because that's an electronic circuit taking the energy from the grid, or the energy from the motor, and transferring that to the battery and vice versa, and managing all the various cells. Or at the same time, the new charger that you can buy for your own computer, which is very compact, because now this is the trend, is done by an electronic engineer, because there's a lot of electronic circuit inside. So it has to do with the amount of energy you transfer. At the same time, especially for photovoltaic plants, but also wind turbines, in most of the cases, they are somehow operating thanks to advanced electronic circuits. So of course, also an electrical engineer can work in that field, but the knowledge you gain with an electronic engineering degree in terms of components for energy, but also in terms of circuits for energy, is very interesting as well. Then, of course, it all depends on what you want to do once you graduate. If you want to work on larger scale energy system, like a nuclear plant or whatever, or thermoelectric plant, then electrical engineering would be better. If you want to work in these other fields, of course, electronic of interest. I don't see other questions in the chat. Neither in the room. So, thank you very much.
Thank you, Matteo. So the next presentation is from Professor Nicola Ferro for computer engineering. Here, from here. Okay. I leave the floor to Professor Ferro. Grazie.
Okay, so good morning, everybody. I'm here to talk to you about the master degree in computer engineering. So, what is the design approach to our program? Basically, we build on two main pillars, which are research excellence, so the research areas in which we conduct our daily research and where we are among the top researchers worldwide, and industrial synergies we have in the research group. In this way, with these two key factors in mind, we designed the study plan, so what we are going to discuss together with the overall goal of delivering autonomy to students and independence. So basically to make you very good and very strong engineers. So, what are the learning outcomes, if you want to use this kind of jargon, or in general, what is the overall aim of the program? Basically, what we want to do is to train a professional figure which is able to deliver core engineering competencies, because obviously we need to share competencies with all the other areas of engineering and be engineers first. And on top of these core competencies, to have advanced expertise in the computer science area, which, as we will see in a minute, is quite widespread nowadays. So it's a very, very huge field. As a professional in computer engineering, you should be able to promote and deliver technological innovation, both in computer engineering itself, but also in related disciplines or related application areas, so to transfer the knowledge you have acquired to new application domains, not only in the profession. You, I think, all know that we are facing a very, very rapidly changing world. The latest revolution is the generative AI revolution that in 3-4 years has completely changed everything. So we want to educate, to train a professional figure able to keep up with this continuously evolving environment and this rapid evolution. As I was saying, we want to have computer engineers with core engineering competencies. Why? Because a computer engineer is an industrial engineer, and she or he has to interact with other areas of engineering. Typically, you work in teams and you may work with electronics engineers, control and automation engineers, with telecommunications and ICT engineers, and with bioengineers. So you need to have the capability of interacting with each of them, and then to provide your contribution from the computer engineering angle you come from. Finally, you are also expected to get out of the program being ready for pursuing a research career, which, guys, is not only academy, but is also industry. So being research ready doesn't mean that you want to work at the university for your whole life, but in most cases it means that you want to work in big tech companies with prominent roles. What is the structure of our program? we have basically some courses which lay the foundations and provide you some core competencies. And then we have 4 curricula: artificial intelligence and robotics, bioinformatics, high performance and big data computing, web and information data engineering. You can choose one of them, and on top of these curricula, you will do either a research training or in one of our research groups or an internship, which can be paired with your final thesis. I will come back to this in a minute. But this is the general organization of the course I'm going to present you in more detail. But before going to the details, what is the end result of all of these? These are data from Alma Viva, Alma Laurea for after 5 years from the degree. The occupation rate is 100% for Padova. Italy 96% is the average of occupation rate of computer engineering in Italy. The monthly salary is on average 2,500 euros, and you see we also have 20% of the students who are pursuing or have pursued a PhD. And as I was saying, doing a PhD is not aimed only to academia, so for doing research at university, but also for doing research and higher level jobs in industry. Because in a PhD, okay, you explore a research topic, you go to the research frontier, but mostly you learn to be really independent, to be really autonomous, to be able to face a problem for which there is not an already given solution, and find your own way to that problem and your own solution. So in this way, you have an expertise and a set of skills which are very valuable also for industry. So what are the program more in detail? What are the core competencies? So we have 3 mandatory courses which are common to all the curricula. One is autonomous languages and computation. If you want, is the calculus of computer science. Here is where okay, is it's strange that we have some comments just on specifically on automata, which is a very theoretical exam. Anyway, so here you learn what are Turing machines, formal languages, computational complexity, and so on. In machine learning, obviously, nowadays is mandatory to have knowledge of the fundamentals of machine learning, and here we have a methodological approach to machine learning. So if you come from our bachelor degree, you may have already had a machine learning course, but it is a little bit more practical and more hands-on, if you like. Here we lay the foundations, and then you learn how to develop machine learning models. Operational research is a very important area to solve optimization problems of various kind. Here in operational research, one especially linear optimization. Besides the mandatory courses, there are other activities which are common to all the curricula. One is English language, Italian language you can take, and as I was saying, you can do either an internship in some company, or you can do a research training in one of our labs. If you pair these, and this activity is 9 credits. If you pair this activity also with your thesis project, you go up to 30 credits overall, and you have the possibility of doing a substantial amount of work, something which also gives you some advantage from a competitive point of view, because you will drill down on some specific areas. I mean, 30 credits is 1/4 of the overall program, so you have to imagine, which is roughly 1 semester of work. Other common features throughout the curriculum is that we go for as much hands-on experience as possible. So courses have some form of homeworks or laboratories or projects that you can develop either on your own or in teams, depending on the course. This is very important because allow you also to develop soft skills like capacity of teamwork, problem solving, also communication, because you often have to present and to pitch your project or your homework. So these are skills that are very useful in when you work outside the university courses. And obviously, being so wide computer engineering, you will also see a lot of interdisciplinary topics across the program. Now I will go briefly in detail for each curriculum. So let's start from an alphabetical order. Let's start from artificial intelligence and robotics. I think there is no need to say why artificial intelligence and also robotics are transforming our world, society, and industry. So if they are revolutions like the steam engine or electricity in the past. So in this part of the program, and you will see now a structure which is common to all the curricula. We have courses which are mandatory for that curriculum, some elective courses which are specific for that curriculum, and you have to pick some of them, like here 3 out of 6. And then there is the free choices, which are 12 credits that you can, in general, pick from any course offered by Unipd. Here we give you suggestions of courses which possibly fit best in the study plan of a computer engineer. So coming to the mandatory courses, we have artificial intelligence, and then deep learning, which are complete the AI side. And then we go a little bit more to the robotics side with intelligence robotics and computer vision, which is kind of bridging artificial intelligence and robotics. When it comes to the elective courses, we have some courses which drill down into the robotics angle, like robotics and control or neurorobotics, but then and also 3D data processing. But we also have courses which are more on the AI machine learning side, like big data computing, learning from networks, and natural language processing. Large language models, ChatGPT come from natural language processing. When it comes to the free choices, our suggestion is to go for quality engineering, reinforcement learning, game theory, industrial robotics, measurement architectures for cyber physical systems, go deeper in operation research optimization, not only for linear problems, and here I have problems saying it, innovation and ship and finance. Okay, so this is for the free choices. When it comes to bioinformatics, we have more and more bigger and more complex biological and medical data sets. You know that much of the research nowadays is data-driven, and biological and medical data are no exception. And in order to be able to process and to analyze this data, you need advanced computational skills and algorithms. Moreover, I think every one of us knows that the healthcare and bioinformatics market is constantly growing, and this trend is expected to continue. So this is what the bioinformatics curriculum is about. One disclaimer, if you want, you do not need prerequisites in biology, chemistry, or medicine to attend this curriculum. Everything will be self-contained, and you will learn techniques which are focused on biological data, but many of these techniques find application in other domains. So, and it will become clear in a minute from the program itself. So, the mandatory courses are bioinformatics, which is, for example, working with 3D, with DNA sequences, or computational genomics, which works with 3D data like proteins and things like this. But then we have general, let's say, more machine learning oriented courses, if you like learning for networks, which is general topic, but has important applications in bioinformatics, because with a network you can represent gene interactions. So this is what you can study. And then you have also inferential statistics, because as I was saying, there is a huge need to do data analytics, advanced data analytics and data science on these data. We have in the elective courses, we go further with deep learning and natural language processing. We have courses on big data computing, search engines, web applications, and distributed systems. So to enlarge your skills in bioinformatics and put them into a wider context. Among the elective courses, you can drill down, if you like, more on the bio side, with imaging for neurosciences, structural bioinformatics, genomics, and NGS data, but you can also strengthen yourself in core computational aspects like advanced algorithm design and operational research too. If we talk about a performance, when we talk about the performance and big data computing curriculum, we know that the data is continuously produced everywhere, and we have a key problem. We need to extract significant information from data. Because we need to analyze trends, because we need to take decisions, and so on. And to do so, we need, on one side, efficient and scalable algorithms, which is, let's say, the computational part, but we also need advanced computing systems like parallel computing, GPUs, and things like this, because we can have whatever computational model, but then we need to run it on real machines. So the course offers inferential statistics, big data computing, parallel computing, and advanced algorithm design as mandatory courses. And then among the elective courses, you can specialize a little bit on different areas where algorithms and advanced performance computation take place. So artificial intelligence and deep learning, search engines, bioinformatics, learning from networks, and you also have the possibility of going deeper into some more systemic aspects of high performance computing, like computer networks and computer networks security. For the free choices, we suggest cryptography, computational genomics, game theory, stochastic processes, and operational research too. The last curriculum is Web and Information Data Engineering. It should be already clear from the previous curriculum that data is the new oil. All the big tech companies make their fortune on the data they have available and how they process them. And the target of this curriculum is to give you wide competencies in different domains, multilingual and multimodal information access, social media, e-commerce, healthcare, a wide knowledge in the different areas of information access, databases, web applications, search engines, recommender systems, semantic technologies, distributed systems, graph databases, and balance this between core engineering competencies and cutting-edge technologies. Nowadays, we all talk about knowledge graph, large language models, retrieval augmented generation, text analytics, and so on and so forth. And as in the other curriculums, to widen your skills with soft skills and hands-on experience. So what does the curriculum offer? Among the mandatory courses, we have computer networks. We need something on the bottom to communicate search engines, web applications, and graph databases. For the elective courses, you can go deeper on distributed computing with software platforms and distributed systems and concurrent and real-time programming. You can go deeper on information access with privacy preserving information access, which is an extremely important topic nowadays, and natural language processing. You can look at another side of information access, which is multimedia, and so we have computer engineering for music and multimedia, and obviously you can also tackle with security aspects related to computer networks. For the three choices, we suggest inferential statistics, quality engineering, big data computing, information security, advanced text analytics, which is another step in information access, and operational research. So, you can find more information about the study program on the department website or on the official Unipd website. You can write to me or to Vice Chair Professor Stefano Guidoni, and if you have an administrative question, our student service is very, very supportive. Thank you very much, and any questions?
There are a couple of questions there. No.
Non questa. Chat, ok. In the AI and robotics curriculum, the robotics part is treated from a more computer science point of view, or it is treated as in other degrees, AG control system engineering. So, let's say, obviously, being computer engineering, it is a bit more computer science point of view. But if you look at the courses, we also have some overlap with control system engineering, because among the elective courses you can choose to have robotics and control one. So obviously in control system engineering is more from that point of view, from the automation point of view, and from in our case from the computer science point of view, from the agents, intelligence agents point of view. All the lectures are in presence, because this is an in presence master degree. It's not blended, and generally there are no recordings of the lectures available. Any other questions? Okay, thank you very much.
Thank you. So the next presenter is Professor Angelo Cenedese, that will present the course in control system engineering. No? Okay, I leave the floor to Professor Cenedese.
Okay, thank you, Pino, for the introduction, and welcome to you all for this presentation of our master's degree. So I am Angelo Cenedese. I'm the chair of the Control System Engineering program, and I will briefly show you our offer. Let's start from our design principle, our motto. So we say that technology is important, but methods and ideas changes much more slowly than technology. So in our program, you will find a sort of optimal balance between what is the technological trend and the methodology, the deep understanding of the method. So we strongly aim at this point. And to build on this motto, we have a program made of 120 or 26 credits, and we offer a very large variety of courses. We have a few mandatory exams that build the, let's say, the basic block of our methodological tools, and we propose 4 paths in what we believe are the most active areas of control. In practice, we do not build our program on curricula, but on paths, which are more, let's say, free in the choice of the exams, and they are all this perfect mixture between methodological tools and, let's say, the more technological applicative side of the computer engineering. All our program is taught in English, and we have a final project that is internship or research training plus thesis of up to 30 CFUs. Clearly, internship and research training can be disjoint from your thesis program, and many students choose this approach in order to study and let's say get deeper into 2 different subjects, but they can be combined into a single let's say, track. So the enrollment requirements are these that I written here, and basically all our degrees, bachelor degrees from this department, and also from the other engineering department I mentioned, aerospace bachelor degrees or mechatronics bachelor degrees are perfectly, also mechanical bachelor degrees are perfectly fine with our program. And since we have everything taught in English, we ask for a certified B2 level. I start with presenting the course catalog. This is the foundation topics. So these are common courses and activities, so the thesis, internship, or research training. And these 5 courses are what we believe are, let's say, the degree of the control system engineers. So we have, they are all during the first year. You have, let's say, a slightly tough first semester with system theory, machine learning, digital control, and more lighter second semester with estimation and filtering, and one of our laboratory, the control engineering laboratory. With these courses and with this prerequisite, you can go through all the rest of our offer. That is, let's say, in one single slide, this that you can appreciate here. Let's say, the bold courses are those strictly related to, say, control systems activity, while all the others are all the affine courses that we we believe are close to our programs. As you can see here, you can find several courses that have already been presented by my colleagues, and indeed our control program is, and let's say the role of the control engineer is to be, let's say, pervasive and transversal to all the to most of the other engineering technologies. But in order to allow, let's say, an easier understanding of what your path can be, we have designed specialized automatic paths devoted to robotics, machine learning, industrial automation, and let's say a more theoretical complex systems path. And within this path, we have already pre-selected some group of exams that can support your choice, but they can also be a starting point for you to create your own path and your own career within our learning. So let's start with the robotics path, and clearly it is unnecessary for me to tell you how much robotics is impacting our daily life. And for robots, we actually abstract the concept of robots into a machine, an intelligent machine with sensor, actuators, and intelligence. So the idea is that a robotic arm is a robot, a mobile robot is a robot, but also let's say, self-driving car is a robot, or an automatism that we may find in the industry is a robot, like an intelligent conveyor belt is a robot for us. So the idea here is to provide you the main competencies in the field of robotics in terms of kinematics, modeling, learning, and whatever. So the core courses of the robotics part, in addition to the foundation, are these 30 credits, so robotics and control 1 and 2, and I apologize with you, the naming here is a bit unfortunate in the sense that robotics and control 1 is referring to the robotic arm with all its dynamical model, kinematic change, and the control of the robotic arm, while robotics and control 2 is related to mobile network robotics. So they want to build let's say, a continuum of 18 credits of robotics, but they are not depending one over the other. So in case you can choose robotic 2 without robotic 1 and vice versa. Then we have convex optimization. We believe that convex optimization, you will see also in the other parts, is fundamental for the model engineer and the computer vision. And then we have designed these 4 packs of exams more related to more applied robotics, so industrial intelligent robotics from our colleagues from computer science and from the mechanical group. We have a laboratory here, robotics laboratory, and we have design of mechanical drives, again from our colleagues from the mechanical department. We have a set of exams from the industrial world, electric drives, embedded electronic control and sensing and measurement systems. Or we have more advanced control techniques, nonlinear system, network harmonical system, adaptive, and MPC. MPC is one of the most used control technique nowadays. Or we have a packet related to the learning point, so learning dynamical systems and reinforcement learning. Our second part is related to machine learning. Again, we are experiencing a flood of data in our daily life, and we need to transform this data, let's say this dumbless data, into smart, intelligent information. And the idea here is to exploit this data, this information, in order to close the loop in a control system. So we let's subtitle this part with control meet machine learning, because here we are merging the let's say the data-driven approach with the fact that we like models, we like build models, in this case from data, and we like to control the dynamical systems. Here, the idea is to offer you a set of, again, 30 CFUs of courses, convex optimization, again, learning and system, reinforcement learning, and computer vision. And then add other elective packages like advanced control, and again, modern control techniques, a package related to models, methods, game theory, neural networks, learning from networks and network systems, and a third small package related to computation and measurements, big data computing, sensing, and measurement system. I repeat, all these are just to, let's say, support you in your decision, because obviously start from one of the paths and then do your mix and match as you like. But here we just wanted to highlight that we have some fil rouge that are running through our paths. Third path, industrial automation. Industrial automation has grown a lot during the last decades. We are not talking about the old automation, but we are experiencing industrial automation, where in the industry now we find man and machine that are working together. So we have the man, so-called man in the loop. We are environments that are spread outside of physical systems, so sensors, actuators, and they need to work jointly in order to produce a whole complex system that is actually increasing the efficiency of the production change, but also the, let's say, the comfort and the lifestyle of the operators. And one of the new keywords that is coming in the last few years is this hyper automation. That is the connection between, let's say, robotics, control theory, vision, and learning. They are all mixed together in our modern industries. And here we can find some examples of what we mean by modern industries. So in order to proceed in this path, we have, again, 30 CFUs with convex optimization, embedded data and control. All the devices that you will find are based on smart, powerful, compact controllers based on embedded technologies, industrial automation, electric drives for automation. Then we have the applied package with industrial robotics, computer vision, design of mechanical drives, and sensing measurement systems. We have a sort of disruptive technologies that are entering more and more into the industrial field, such as reinforcement learning, information security, and adaptive MLPC, model predictive control. And finally, we have some methodological courses like learning dynamical system and the two robotics and control courses. Our fourth and final part is that related to complex systems. It does not mean that the other systems are not complex, simple. If we think about a set of robots that are working jointly, it is a complex system. But in this case, the idea is to offer to you a path that is somehow more theoretical, more methodological. And in this, we can highlight some classes of topics, such as nonlinear network, biological, or quantum systems. It is important for you, for me to say to you, and for you to understand well, that all these four paths are perfectly equivalent, both for, let's say, an industrial career or a research career, both here in the academia and in the industry. And we can also discuss about the distribution of our students, but they are all a mix and match of these paths. Also here that are our PhD students, our fellow researchers, or colleagues in the industry. So here, the 30 CFUs is composed by learning dynamical system, convex optimization, mathematical physics, and nonlinear system and control, so more theoretical stuff. We have a package related to non-linear dynamics, so network dynamical system, reinforcement learning, and the two robotics and control courses. a package related to algorithms and information, so learning from networks, automata, languages and computation, quantum information computing and game theory, and final, a package related to the systems biology, so the course of systems biology, control biological system, and mathematical cell biology. So this is the presentation of our 4 paths. In addition to this, I want to say that we have, so in the presentation of the course, you may have spotted some, let's say, laboratories in our paths, so robotics laboratories, control system laboratories, embedded data control is a laboratory course, industrial automation as well. Here we have 2 research laboratories that are actually a glimpse of what you can find outside by following our paths. We have an industrial application laboratory that at the moment is hosting a robotic arm system, Bucketown, that is this miniature smart city system, and a driving simulator, that is this system here, and this is the industrial application laboratory. And we have the Spice laboratory that is more focused on mobile robotics, both ground and aerial robotics. And here we design algorithms for estimation, perception, and control of such systems. Then another important thing that shows you how, let's say, transversal we are. Our students take part in several students projects. So some of the students projects, some examples are this photo you can see here. So the CubeSat projects in collaboration with our colleagues from the aerospace group, the RESAP team with our colleagues from the industrial department. The Bosch Future Mobility Challenge is our own, let's say, flagship project, and currently now our students are in Cluj in Romania during the final phase of this challenge. And the UNIZEB project is another project, a living lab coming again in collaboration with our colleagues from the industrial departments. So here the control systems are fundamental in connecting devices, in producing predictive, let's say, trends for these complex systems. And here we take part more as, let's say, an important part in these projects. As for the career opportunities, we are present in the industry, in the automotive fields, in the automation and robotics, in home appliances, in power and the energy, and a very variety of manufacturing industries, both from the technical side and from the management side. Since we know the technical part, we can also take part at the, let's say, top level of the managing roles in these industries. And obviously, several of our former students are faculties in other universities here in Italy and abroad, or researchers in research institutions. This is a part of our collaborative networks where I highlight 3 groups. The magenta block is related to universities, most prestigious universities worldwide, so from the Far East to the American or Australian universities and the European ones. We have in the green block, in the green box, we have research institutions, so starting from the Italian CNR to the CNRS in France to the ESA group or other, and in the light blue, a little part of the companies that are working with us and where most of our students are hosted as students or as trainers for the initiative process. And with these smiling pictures, I conclude my presentation. This is the group of this is the component system. So I will be pleased to receive your questions.
There are a couple of questions in the chat.
Okay. So why specializing controls by choosing this path rather than choosing another path and only taking some optional exam control? Features are much important. Usually is to know control. Okay, this is a nice question. So first of all, the idea that we have in mind is that with the foundation part, you can, let's say, go everywhere you like. So my suggestion is that you can start from a path that is you find more convenient for you, more closer to your expectations and your abilities, and then you can modify that in due course. One path or the other are not let's say shaping your professional profile in a, let's say in the strongest way. And clearly with this path they are more, you can start from one and just change some of the exams, or you can do your own path. The paths are here in order to support your decision, so that you don't find you're lost in this, let's say, huge number of courses and you don't know what to choose. So feel free and also, let's say, feel relaxed in choosing the exams that you like, because this is the main suggestion that I can give you. And then theory versus control is the, let's say, the everlasting question. Clearly, control theory is not mathematics. It is, we are in the Department of Engineers, so you need to end up with the control applications. You may develop this as a more, let's say, theoretical level. You like creating models, but at the end of the day, you know that you have a device that you have to control. So at the end of the day, you will, let's say, find yourself finding with something, a vehicle, a robot, let's say, a dynamical system that you need to understand and control. And by dynamical system, let's say the human body is a dynamical system, a population of salmons in Alaska is a dynamical system, a robot is a dynamical system. The nice approach that we have is that with the same toolbox, you can jump from the population of salmons in Alaska to the nuclear fusion plant with the same toolbox. And this is the strong aspect of, I believe, this strong aspect of control theory. The fact that the requirements include the bachelor's degree in computer engineering and electronic engineering is because the computer engineering is alpha between electron computer control something to both. So but we ask a foundation in the affine topics. So we need to understand electronics. We need to understand computer science. We need to understand, let's say, the basic physics of the systems. But it is not true that we require a bachelor in computer engineering or electronic engineering. All our bachelors are built in a way that you arrive at this point with enough credit and enough expertise to choose whichever you like of our master programs. And I believe this is the message that has been given to you also by my colleagues. So if you are, let's say you have a bachelor in bioengineering, you can get to our control systems. If you have a control system like automation bachelor, you can go to computer science or to electronics or whatever you like. So we build our paths in a way that from our bachelor's you can get to any of our masters. And I like to extend this also to other, let's say, cousin bachelors, such as the aerospace or colleagues from Vicenza, from the electronics departments, and other fields. So no more questions here. Yes, please.
About this requirement to join the master.
Yeah.
I saw in a conference system there is required more CFU than in the quattro.
Yes.
Then how many the bachelor of science need.
Yes, you're right. This we can manage because yes, sure. So in the let's say in the formal requirements, we ask for a specific number of CFUs in the automation topics, while some of our bachelor degrees do not hold this exact amount. And the reason is that there is a donation given by this classification of CFUs. And just to mention this, machine learning for us is automation. For the colleagues in computer science is different. Let's say computer science in Gen 05, I believe. So the idea is that if you have some of the courses that we believe are automation, we let's say we rule out this prerequisite. And some of the courses are, for example, optimization, are machine learning, are modeling. These are all topics that are related to the automation disciplines. Then in other bachelor's degree may be flagged with other codes. If we see that you students have some of these, we consider those as part of the automation block. So it is, let's say, a formal requirements that can be skipped by the colleagues that take that look through the application of the students. So there is no problem with control, in particular with computer engineering. There is no problem with the ICT colleagues that recently have reflagged some of the courses, and they do not meet perfectly our requirements. There is no problem at all with you.
Okay, thank you. I have another question.
Sure.
Which is more appropriate for those interested in autonomous driving? It's more appropriate to choose control system or maybe
Nicola, do you want to come here and we can
have a fight?
So it is up to you. So let's say clearly it is similar to the question that has been asked before about robotics. We both have the robotics path. From our point of view, is more, let's say, methodological. We look at the basic principles. We start from the basic modeling of the robot. So in our case, for example, we start from the unicycle modeling, and we do this in all the different ways. We approach the autonomous driving problem from the basic control features that are needed for a vehicle to steer, or for a vehicle that has to carry the specific load and so on. So we start, let's say, for the basic piece. Our colleagues from the computer science often see the very end. For example, in our course, it is difficult to see the humanoid robot because it is the end of the whole process. In our course, you see all what is needed to build a humanoid robot. You see the connection between perception and control. You see how you can close the loop with the data-driven models in between. You see how you can manage, coming back to the autonomous driving, with the human in the loop in driving the car. So in this case, you need to take into consideration the fact that you have a human if you want to do an assisting driving technique or procedure, or you have a human that is collaborating with the vehicle. Because, for example, for transportation, we have autonomous vehicle and humans that are carrying together a load. So in this case, you are designing an autonomous vehicle that is working jointly with the human. So if you like to see all these principles that later you can apply to several different aspects of robotics, of the self-driving cars, autonomous systems, and so on. Control system engineering is your part. But I invite you to, let's say, discuss with my colleagues from the computer engineering. You're welcome. Any other questions from you or from home? If not, I thank you for your participation and I leave the floor to our coordinator.
Yeah. And the next presentation is from Professor Nicola Laurenti that will present Cybersecurity Master. Okay. What's yours?
Okay, so thank you. So let me. Can I hide this? Okay. Okay, so I'm here to present the master degree in cybersecurity. Passare alla successiva. Sorry. Yeah, okay. So, rather than, okay, I'll have some slides with a detailed list of the classes, but I will not go in detail to them. And I would rather prefer to introduce what are the principles that drive this master program. Okay, so it's an exception in Italy, in the national Italian landscape. Usually, cybersecurity is seen as a particular curriculum within an existing master degree. So that is typical computer science or computer engineering, sometimes telecommunication engineering. Throughout Italy, there are only a few master degrees in cybersecurity. It's called the Classe di Laurea LM66 Sicurezza Informatica. There are only 8 of them. One of them is in Padova. However, most of the others are given by a single department, okay, mostly computer science departments, and somehow there's sort of technical part and some maybe business or law skills. What we want to do in Padova, however, is to have a joint interdisciplinary effort from several departments. That includes, of course, this Department of Information Engineering, from the scientific and technological aspects, the Department of Mathematics from the scientific and computational aspects, and other departments such as psychology, law, and business for all these social aspects, psychological aspects of cybersecurity, which are more and more relevant in the job landscape today. So we want to deepen these 3 core areas of expertise from the point of view of this department is by strengthening the aspect on the engineering part, on the physical layer part, and on the communication and computer engineering part. There's also a strong innovative, but of course now common to many of these master program in this department, perspective from the machine learning side. But we also have this, as I said, the aspect on the psychological aspects, on legal aspects, and so on. From the point of view of the scientific part, we know that the contributing departments have very strong research in several fields, including, of course, many areas in the cybersecurity, but machine learning, artificial intelligence. Maybe it's better if I sit for the, okay. Like big data, telecommunication networks, as you see, quantum communication, quantum cryptography, cognitive neuroscience, but also on the aspects maybe less related to the technical, let's say, computer and network aspects, such as forensics and legal aspects, the human-computer interaction, and the neuroscience aspects. We also rely on strong industrial connections between the instructors in both departments, but also with the labs that we have, and with cooperation with many companies in different areas that all need security nowadays. Some of them provide security services, clearly. Some of them employ security service. But even if they employ security service, they don't just buy security as a single product. They need to govern their own security. So they have explicit areas of the company that are meant to control, to rule, to manage the security of the company information assets. And you can see here a full list. So how is this made, more or less? So as I said, it's highly interdisciplinary. Three main areas of expertise. One scientific, from computer science and math. One technological, more from engineering side. And the other from law, psychology, and business. I should mention that because we are in the engineering department, even if you take this interdepartmental master program, you will still be allowed to take the exam for professional qualification as an engineer. Okay, so that will still also allow you to take that. So it's not, let's say, a math master. Okay, overall in the organization, the master is full in English. It's an international master. It has, of course, the usual 120 ECTS total. All the classes are 6 ECTS. There are 60 mandatory classes, 60 ECTS for mandatory classes that are more or less divided into basic course from core security topics, some additional methodologies that are not strictly speaking security, but that support cybersecurity, and then some more advanced topics that we want you to have anyway. And then you have 12 ECTS of elective courses in like constraint choice, and 12 more ECTS of completely free choice, and these are typically used by our students to build their own path on like more advanced topics, or more topics that are more related to their own interests and their own likes. Okay. And then the English 3 ECTS and 3 ECTS for extra activities such as seminars and projects, the master physicist 30 ECTS. Okay, so here just to see how the study program is organized. I said we can split the classes into like more foundational security-oriented courses, then fundamental methodologies that are not strictly speaking security, but are supporting security, and then advanced and specialized courses. And on top of this, we also have some transversal skill courses. Okay, so for instance, mandatory courses are fundamental cybersecurity and cryptography, fundamental information security, quantitative metrics. Then for supporting methodologies, we have machine learning, cognition computation, deep learning, stochastic processes. For advanced and specialized courses, you can get to the digital forensics or advanced topics in network security. Okay, and then the cross the transversal courses, which can be with one course to be chosen among human-computer interaction, law and data, or service management. When it comes to the elective courses, we have more or less the same division. Of course, there are many more classes here. I will not list all of them, but these are the more foundational security oriented. Okay, so you can see the quantum part or the ethical hacking part, the mobile security part, machine learning again. Supporting methodologies, we can range from game theory to web application to formal methods for verification, and advanced specialized courses. We can go from networks to vision systems, Internet of Things, and so on. What is the job that our graduates typically land? Well, of course, mostly they are top jobs in the security, but it can be, as I mentioned earlier, both from organization and company that provide security service, build security service, or sell security services or products, but also in companies that use this employee security service and have an internal structure that is meant to evaluate where the security service is the one that is needed for the company, is properly tailored and properly designed. Okay, so if we want to wrap up the master program, it's very solid, okay, with strong background on core security topics. These are the most, let's say, from the mathematical, also and theoretical, analytical point of view, very sound. There's solid knowledge of underlying technologies, methodologies, and principles, which we borrow by sharing these classes with other program in this department or the math department. And then there's an understanding of also cross-disciplinary implication for security aspects, because security must also be usable, welcome to the user, should also be cost-effective, should also be socially working, socially effective. So this also provides this. Okay. Okay, well, this because the class is, the program is fully in English, so you need to have a B2 certification. You can take the exam here, of course, in Padova, or come up with a pre-existing certification. Okay, here are references, but I would like to spend the last 5 minutes to point out a separate path inside the cybersecurity, which is the joint master program, European master program with the Arcus University Alliance in international cybersecurity and cyber intelligence. And it is a joint master program because it's provided by 4 universities at the same time. One of these universities is Padova. The 4 universities each provide a different research expertise and teaching methodologies. And this also offers the students for this path to travel among the 4 universities and study in each of them in a fully international cohort. So also developing some soft skills in flexibility and international approach and intercultural sensitivities. The idea is that the student will move at each semester. They start their first semester in Padua, they spend the second semester in Vilnius, Lithuania, they spend the third semester in Granada, Spain, and then the fourth semester is actually spent during the master thesis, often with internships, so it could be anywhere in the world, let's say anywhere in Europe at least, but then it's ended with the final graduation defense final exercise in the University of Minho in Portugal. So here's the curriculum structure. At Padova, you have 3 mandatory classes and 2 out of 8 electives, and the classes you take at Padova are some of those that are also taken by the standard curriculum of cybersecurity. So you share the same classes with the students of the local cybersecurity master. And then you have some dedicated classes in Vilnius University, which are more related on laboratorial aspects. And finally, in Granada, you get classes that are, some classes that are related to the geopolitical notions, geopolitical aspects of international cybersecurity And as I said, University of Minho is the final part, the thesis defense, and a final team exercise where you have to attack and defend the certificate. Okay, I'll go quick through the list of these. These are the mandatory classes for this program. As you see, 2 of these classes are also among the classes that you take at Padova anyway. These are also the elective classes. As you see, the red ones are the ones you can take at Padova. You can choose 2 of these according to your needs. Just one point, the admission procedure. The admission is limited to 30 students per year to this program because the mobility of the students must be funded by Erasmus scholarships, and therefore there's a limited amount of funding available. For the submission is done once for the whole consortium of universities. Okay. Of course, you need a bachelor in IT disciplines, motivation letters, recommendation letters, again a B2 English level, and you will take an interview with the selection committee, with the international selection committee, to assess whether you are a good fit for the program, whether the program is a good fit for your expectations. Okay. The final title is awarded by the 4 universities jointly. So that's not you don't get a title from Padova and a title from Granada. You get a title from Granada, Padova, Minho, and Vilnius jointly. That's it. I think I've done with my presentation, and of course I am willing to take questions on both of this. I should point out that this should be viewed as this last International Cybersecurity and Cyber Intelligence as a path inside the cybersecurity program, but for formal reasons, administrative reasons, it is listed as a separate master program, a separate corso di laurea magistrale. But instead, as you see, it shares a lot of the classes and a lot of the methods that are also for the cybersecurity. Okay. So I apologize if I went too quick, but of course I'm willing to take questions. So please go ahead. Let's see if I can.
There are a couple of questions in the chat.
Okay. Should I look at it here? Dove lo vedo? Qua? Okay. So 2 new questions. Okay. Will the lecture be in person only, or will it be telematic offline teaching for full-time working students? Okay. So in the cybersecurity program has I think that's one class that is blended teaching, and that's the cryptography. There's the cryptography class. Cryptography and fundamental cryptography cybersecurity class. The rest of the classes are in person. Some of the classes have recorded lectures that are then shared. However, some classes also have like laboratories, and so in presence. So I would say that attending in presence is required for more or less at least 50% of the time. Okay. Given this is a course with semester, question from Filippo, given this is a course with semester in multiple countries with different laws, will the university entry fees be adapted according to IC ratings both in Italy and abroad, also their housing guide? Yes. Okay. So yes, I gave I gave the link in the presentation. The presentation will be shared. You can go to the Arcus University Alliance webpage and look for the Master in International Cybersecurity and Cyber Intelligence. And there's all is explained there. So there is housing guidelines for all the 4 countries, and you are followed by the housing departments. The students, because this is program with limited admission, the student for only 1 semester, the students that are admitted have priority in housing and accommodation, because otherwise it's not easy to find accommodation for just 1 semester if you go on the private market. You know, if some of you have tried getting houses in Padova, you know this is complicated. So yes, you have housing guidelines. As for entry fees, yes, entry fees are balanced. They are computed as a sort of average between the entries for different countries, whereas the adaptation to the ICE is I don't think it's applied, but for this you should ask the international office at the university, University International Office. A third question says, if it's possible to, sorry, let me do this.
Unfortunately, that does not appear on.
So it's okay, yeah, okay.
Io non so perché non compare sullo schermo.
Online. The questions do not appear now. Okay, that's fine. Okay, but those that are online, you can look at the chat and you will see the questions. So there's a question from Marco who asks whether it is possible to examine the syllabus of this Arcus degree in International Cybersecurity and Intelligence. Yes, the full syllabus can be seen in the web page in this program website, which is the one. Okay, so if you go to let me go here to the here. If you click on this QR code here, then you will be taken to the you will be taken to the web page that describes the cybersecurity program in the from the Arcus University Alliance, in the site of the University Alliance. If you also look for the syllabus in the in the Padova Didactica page, you would only find, I think you find only the classes that are offered here in Padova, so just the first semester. Okay, yes, so I should say that registration for this international program ended already for the next for year 25-26. For the court, of course, this is you can apply for the court 26-27. Okay, so that's because the reason why this ended in May, and as we said, is because we need time for the evaluation process, and then so it's and because we have to fill the 30 available seats places early, let's say, for all the visa procedure and so on. Okay. Any question maybe on the standard side on the cybersecurity, interdepartmental cybersecurity? Okay. That you have. Okay. So if there are no further questions, I think we can stop here.
Okay.
And
thank you, Nicola, and thank you all for the attention to this morning session. I hope this was give you a lot of information, and of course, if you have any other requirements of a question, you are free to ask also to go to the didactic secretary. Okay, so thank you very much, and also for the people that are online. So see you next year a day. Bye bye.